What could be the maximum number of planets that can exist within a solar system? There are 8 planets in our solar system, but how many planets, such as Mars or Jupiter, might circle within our solar system without harming Earth? How many planets are there in the solar system? Let us investigate. What exactly is a planet? To determine the approximate number of planets that could fit within our solar system, we must first define the term planet. A planet is a celestial entity that orbits a star and is massive enough to have gravity, allowing it to have a spherical shape. The Sun is orbited by 8 known planets in our solar system. Each planet is distinct in terms of size, composition, and environmental circumstances. Venus, for example, is the hottest planet in the solar system, while Neptune is the coldest and farthest away. Planets arise from the gas and dust disk that surrounds the star they orbit. As the disk cools and condenses, little objects form, which mix to become planets. The composition of a planet is determined by its distance from the star and the number of materials present in the protoplanetary disk. For example, if the disk contains many complex materials such as carbon, iron, or zinc, the resulting planet will be rocky, whereas if the disk contains primarily gases such as hydrogen and helium, the resulting planet will be a gas giant. Dwarf planet. Then there are the dwarf planets, the planet's more minor brethren. Although it is commonly assumed that the primary distinction between dwarf planets and planets is size, this is not the case. The primary distinction between a planet and a dwarf planet is that the former has not cleared its orbit of other objects, whereas the latter has. This means that, like a planet, a dwarf planet orbits the Sun, but there are other things in or near its orbit that it hasn't ejected, and they occasionally get in its way. In contrast to a planet that has completely swept its orbit of any other object and does not clash with anything throughout its whole trip around the Sun, a dwarf planet collides or passes very close to numerous objects on its way around the Sun, primarily asteroids. The International Astronomical Union, IAU, created a formal definition of a planet in 2006, which defined 3 conditions for an object to be recognized as a planet, which are as follows. 1. It must revolve around the Sun. 2. Have enough mass to be spherical. And 3. Have cleared its orbit of any other objects it may encounter on its path around the Sun. A planet cannot be categorized if it does not match these 3 characteristics. Ceres, Pluto, Haumea, Makemake, and Eris are among the known dwarf planets in our solar system, with more predicted to be discovered. Dwarf planets, despite not meeting the precise definition of a planet, are critical for understanding the evolution and diversity of the solar system. How little can a planet get? If we wish to populate the solar system with planets, we should start with the tiniest ones. Making numerous planets very small allows us to set them in orbit around the Sun without their gravitational fields impacting Earth. This is due to the fact that the smaller a planet is, the less mass it has, the less mass it has, the less gravitational force of attraction it has. However, keep in mind that the second condition for an object to be classified as a planet is that it have enough mass to have a spherical shape. But how big is this mass? To be spherical, an object must have enough mass and gravity to compress its material toward the center while also balancing its gravitational force in all directions. The minimal mass required to obtain a spherical form is determined by the object's composition and the gravitational force it encounters. In general, an object with a mass of at least a few tenths of the mass of the Moon is required to acquire the spherical shape. However, this is merely a rough estimate because the precise amount of mass required might vary depending on the object's composition and density, as well as the speed of rotation and other factors. Ceres, for example, a dwarf planet in the asteroid belt between Mars and Jupiter, has a mass around 0.00015 times that of Earth, yet is massive enough to be spherical due to gravity. Due to its lower mass and gravity, the asteroid Vesta, which is substantially smaller than Ceres and has a mass of only approximately 0.00002, the mass of Earth, is not spherical. In summary, the mass necessary for an object to be spherical varies depending on composition, density, and other parameters, but in general, a mass of at least a few tenths of the mass of the Moon is required. That is, if an object the size of Ceres orbited the Sun in a clear orbit devoid of asteroids, it should be categorized as a planet. We already know a minimal size, now we must track the distance. What is the shortest distance that planets the size of Ceres might be placed? This is a trickier subject because the planets do not always have the same distance between them. Remember that the planets' orbits around the Sun are elliptical rather than circular, thus they move towards and away from the Sun as well as towards and away from each other. The minimum distance that the planets can be separated depends on many factors, including their mass, orbital speed, and gravitational disturbances from other celestial bodies in the solar system. It should also be noted that the planets occasionally get very close, which has no effect on Earth. Certain orbital configurations allow the planets to be relatively close to each other. For example, when Earth is directly between the Sun and Mars during an opposition occurrence, the minimum distance between the two planets may be around 55 million kilometers. Another near encounter with Earth happens at Venus's inferior conjunction, which occurs when Venus is between Earth and the Sun. The shortest distance between the two worlds is around 40 million kilometers. That is the shortest distance between two planets in our solar system, but things alter when we look at other solar systems. Resonance in orbit. Orbital resonance, also known as orbital synchronization, happens when two or more celestial entities are sufficiently near that the orbit of one affects the orbit of the other. Several planetary systems have planets with synchronized orbits, especially when the planets are fairly close. The Kepler-223 planetary system, which is around 1,200 light-years away from us, is one of these systems. Kepler-223 is made up of 4 planets with approximately circular orbits that are arranged in a chain. The 2 outer planets are in 4-to-3 orbital resonance, which indicates that the inner planet completes 3 full orbits for every 4 complete orbits of the outer planet. The 2 inner planets in the system are also in 4-to-3 orbital resonance with each other, which means that the outer planet completes 3 full orbits for every 4 complete orbits of the inner planet. The gravitational interactions between planets as they orbit their host star are thought to cause this form of orbital resonance. As the planets interact gravitationally, they can exchange orbital energy, synchronizing their orbits. This phenomenon may also be observed in our solar system on Jupiter's moons, where the orbits of Io and Europa have a 2-to-1 resonance, which means that for every 2 rotations Io completes, Europa completes 1. In turn, Io and Ganymedes have a 4-to-1 resonance, that is, for every 4 turns made by Io, Ganymedes makes 1. Jupiter and Saturn have orbital periods that from 5 to 2. This means that for every 5 turns Jupiter makes around the Sun, Saturn makes 2. The orbital synchronization of planets is determined by their proximity, size, and mass. Therefore, the greater the planet's mass and proximity in the solar system, the more likely they are synchronized. Knowing this, the number of planets that the solar system may support will be determined mostly by their size and distance from the Sun. The minimal size might be similar to that of Ceres, and the minimum distance would be the distance between Earth and Venus, which is around 40 million kilometers. Assume they are minor planets such as Earth or smaller ones such as Pluto or Ceres. In that situation, they will be able to fit a considerable number, given that there are at least 20 objects in our solar system that are similar in size to Ceres, particularly the natural satellites of the gaseous planets. An exact figure is impossible to calculate. However, it is conceivable to establish that our solar system could accommodate at least twice as many planets as it now does without their gravitational forces interfering with the orbits of other planets. Even more would fit if we deleted the gas giants and replaced them with more minor rocky planets, because rocky planets are so much smaller. So a solar system with up to 30 tiny rocky planets may exist without issue. However, nothing like this has been discovered so far. What is the maximum size of a planet? On the other end of the spectrum, there are mass restrictions on the side of the large planets, albeit the distinction between what is and is not a planet is less apparent. The International Astronomical Union declared in 2006 that a planet's mass limit is 13 times that of Jupiter. This value was chosen because it was calculated that once this mass limit is achieved or exceeded, gravity will crush the planet, causing the atoms in the core to fuse and the planet to become a star. Years later, when we discovered giant exoplanets, we discovered exoplanets the size of Jupiter or larger, orbiting incredibly close to their star. These planets are known as hot Jupiters because their surface temperatures are frequently searing, often surpassing 1000 degrees Celsius. In other words, these planets have the same temperature as brown dwarfs. Brown dwarfs are a type of failed star, that is, a substellar object that has a mass greater than that of planets but does not have the mass required to initiate nuclear fusion in their core, preventing them from becoming true stars. This classification was devised because they sought to implement a method to separate planets and stars, but later. What about the red planets? They're either gas giants or brown dwarfs. Even astronomers are not certain. As we can see from the maximum boundaries, the classification of what is and is not a planet is not obvious, which is crucial if we wish to fill our solar system with giant planets like Jupiter or brown dwarfs. There would be no room for so many. We could only fit 2 or 3 planets like Jupiter before their orbits collided, causing a gravitational attraction that would result in them colliding and merging into a single object, possibly forming a star. There are stellar systems in the cosmos where 2 or more of these objects can silently orbit their host star. However, despite the immense distances between each planet, our solar system is rather small in comparison to others. There couldn't be as many as Jupiter without their massive gravitational pull endangering life on Earth. Alright everyone, here's where the video ends. Thanks for watching and don't forget to like, share and subscribe.